Welcome to Schweitzer Drive, a podcast where we explore what goes on between the generation of electricity and the light switch. Join Dave Whitehead as he interviews the entrepreneurs, innovators, and experts who are inventing the future of electric power.
Hi, welcome to Schweitzer Drive. I'm Dave Whitehead, CEO at Schweitzer Engineering Laboratories. And today we're going to talk about education, something I find extremely fascinating, especially when we talk about this electric convergence or electrification of everything. I think training is going to be so important going forward. Specifically, the ongoing education and training that is critical to the electric power industry. My guest today, Dr. Hector Altuve, is especially qualified to discuss this topic. He has spent the first part of his career as a university professor of electrical engineering, and for the past 20 years, he's worked to provide and promote education within the electric power industry as the dean of SEL University. Dr. Altuve earned a Bachelor of Science in Electrical Engineering in 1969 from the Central University of Las Villas in Santa Clara, Cuba. He earned a PhD degree in 1981 from Kiev Polytechnic Institute in Kiev, Ukraine. He served on the faculty of the Electrical Engineering School at the Central University of Las Villas, the Autonomous University of Nuevo León in Monterrey, Mexico, and was a Schweitzer visiting professor in the Department of Electrical and Computer Engineering at Washington State University. He joined SEL in 2001 to help us establish SEL University and served as a research engineer. Hector has authored and co-authored more than 100 technical papers and several books, earned 4 patents, and holds the distinguished title of IEEE Life Fellow. And you just got that award recently, isn't that correct, Hector?
Very recent, January 1st this year.
Again, congratulations and well-deserved. Thanks for taking the time to talk with me today. Let's get into this. What is the mission of SELU, and will you tell us about your role as the dean of SELU?
The mission of SEL University is to provide the education and training needed to make electric power safer, more reliable, and more economical. So SEL University helps meet the urgent and increasing need for technical training in the electric power industry. And I consider this important because the power system assets are aging, and so are the power industry workers. The power system is evolving. University power programs have steadily declined, both in number and in quality, so they are beginning to recover now. So there was a decline of these programs. They are partially recovering now, but this was a problem we had in education, and the industry depends on skilled workers. So SEL University training is for engineers and technicians from electric utilities and industrial companies, for consultants, and for university professors and students worldwide. We have had a significant numbers, even of university professors and students in many of our courses in many countries. And to the second part of your question, my role as the SEL University Dean is to expand the course offerings, continuously improve the course quality, lead the SEL University instructor certification process, and keep track of instructors' performance.
So let's rewind back to 2000 when SELU was started. I want to maybe I'll combine 2 questions with this. Is what initially was the problem you were trying to solve or need you were trying to meet with starting SELU? And then I went to school for 4 years, and essentially I had about enough time to learn Maxwell's equations and Ohm's law and a handful of other things. Where or do you see a gap between what a university should be providing in terms of education and then what perhaps industry or specialized training should provide? What are your thoughts on those 2 questions? What problems were you initially trying to solve, and how has that evolved as the electric power system is certainly there's more technology being applied to it than there was, say, 20 years ago, 22 years ago, if we're being factually correct on our number of years.
Prior to SEL University, SEL had developed a family of application courses to teach our customers how to apply and how to test our products. In 1999, when I was serving as a Schweitzer visiting power professor at Washington State University, Dr. Schweitzer asked me to work on creating a new family of fundamentals courses to supplement the application courses. And this is something Dr. Schweitzer knew I was already doing in the University of Nuevo León. I had a 1-week course, which, by the way, now is Prod 401. And for a number of years, I taught this course for engineers in Latin America, in many countries. And some of these years, Dr. Schweitzer would travel to Monterrey to co-teach these courses with me. So he really knew these courses. And I think this is why he requested me to start creating the SEL University, a family of fundamentals courses. Not many universities offer power system protection, automation, and communication courses. This is a problem I have found in many universities. You have even good power system professors, but protection technology, protection and automation technology requires specialized kind of hands-on knowledge that not many university professors have. So to fill this gap, SEL University offers today 56 courses, and we continue expanding these offerings.
So what I see interesting about SELU, I think there's two sides to it. One is, say, the application side, where it's, hey, I've got a brand new traveling wave relay. How do I go about setting the various elements in it to get the most performance out of it? I think the other side of it, where we have the fundamental side of teaching, I think we're offering our industry a real service. I think you pointed it out. I think you nailed it. Is we have a lot of great professors at universities that can teach you broad stuff, like here's symmetrical components, or here is how motors operate or work, and what have you. But I think with the value listening to you and having sat through a handful of your courses is, how do you take those very specific concepts or ideas and then apply them to actually doing something on the power? So how do you really protect a transmission line? How do you really protect a generator? And so it's kind of taking the theoretical side and the practical side, merging them together so that engineers can learn really the fundamentals for protecting a power system versus some theoretical, well, here's symmetrical components, is what an A to ground fault looks like in symmetrical components, and so on and so forth. That's really interesting. So let's follow on that. Where do you see the gaps in learning with industry? Is it between what students learn in school versus where they join the workforce? Are there gaps in their mid-career learning? And is this always going to be an ongoing challenge for people as technologies evolve? How do you keep a workforce up to date with the skills they need?
To answer your question, Dave, I need to go a little bit back to the basics. I would say that education has two phases: formation and instruction. Formation is about values. It prepares youngsters to be good human beings and good citizens. Formation is a shared responsibility of both the family environment and the education system. Instruction, on the other hand, is about conveying knowledge. It prepares students for their professional life. Instruction is mainly a responsibility of the education system. Speaking specifically about engineering instruction in universities, it includes two general types of courses: science courses and specialization courses. That the content of science courses, math, physics, chemistry, does not change significantly over time. And in general, universities offer good science courses. The problem is the content of the specialization courses, because they should change very rapidly in order to follow the technology advancements. And not many universities offer good specialization courses. This is the gap we are trying to close with industry. specialized training. Because of the rapidly changing nature of specialization course content, an important role for universities is to develop students' self-learning skills. That's another important task for universities. They should prepare students to self-educate, to search out and digest information by themselves, because it will be an extremely useful skill in their professional lives. So formation and the creation of self-learning skills together with teaching science courses, this is where the universities are good at. The problem is specialization courses. And I would add that once young engineers start their professional lives, the need for continuous education appears. This is a process that goes on for the whole life of the person.
I think you're spot on. I'd agree with you 100%. The electric power industry is rapidly changing. I'm sure you can attest to seeing that throughout your 40-plus year career. Government-led goals and mandates related to decarbonization are creating some very significant challenges for the industry and at an accelerated pace. In addition to all of the work being done to integrate new sources of generation into the grid, figuring out energy storage, and the monumental task of building new transmission networks to support all of this, there's also a steep learning curve for professionals who are working to keep pace with the changes. In terms of education and training, how do you think industry should or will manage this in the years ahead?
In the past generation, mainly composed by synchronous generators, was reliable, provided stabilizing inertia to the power system, and was under full control of power system operators. Generation was there, was reliable, was not weather dependent, was dispatchable. New renewable sources are taking a growing portion of the generation mix. These distributed sources include weather-dependent wind and solar sources, which are difficult to dispatch and add no inertia to the power system. So these are two significant differences. If a cloudy day appears, then you have no solar generation. If the wind gods decide not to blow anymore, then you lose all the wind generation, and this happens. For example, in West Texas, frequently there are times in which they have more than 25% of wind generation in their mix. And if you have a problem with wind, then you lose everything. And this is why you need backup batteries. Instead of having backup synchronous generation, you need to have something else. So these distributed sources, which are difficult to dispatch and add no inertia, and this is the other problem, when you increase the percentage of non-conventional sources, you are adding megawatts of generation, but you are adding no inertia. And when you have a short circuit in the power system and you have power swings in the system is more prone to lose stability when the online inertia is low. So this is another problem with these sources. And in addition, they are connected to the system through inverters, which limits their short circuit current contribution. So they hide the faults. They make faults more difficult to detect. That's another challenge for protection. To add to this mix, investments in transmission are lagging the pace of load growth. So transmission systems have lost redundancy. Transmission and sub-transmission networks, in addition, need to be expanded to close this gap and to additionally accommodate all these distributed generation sources. And one more problem is that many modern loads are electronically controlled, which reduces their resiliencies. They are more brittle, more affected by power system, power quality problems, so they create higher power quality requirements. The result of all these changes is that today's power systems operate close to the security limits. They operate close to the edge of the cliff, as I used to say in class. They typically withstand only single contingency, the power system 40 years ago could withstand double contingencies, meaning losing two large generators or two important lines, or one large generator and one important line, and they could remain stable. But now you can hit a system only with a single contingency, because if you get to a double contingency, then unless you have a very good power system protection and control system in place, you will have a large-scale blackout. And this has been happening more and more frequently in many countries. So these systems depend to deal with the second contingency on a more advanced power system protection and control system. And of course, very, very experienced engineers.
So isn't there an opportunity then? So power systems are changing. That's a fact certainly from an education standpoint, then bring in new skill sets, new technologies, right? To deal with the changing power system. We could take a look at, inverter-based resources now getting applied to the grid, bringing on solar or wind. As you pointed out, not having inertia like a big spinning generator might. And that's an advantage for, say, traveling wave technology, right? Operates very, very quickly. Doesn't really care about the inertia behind the machine, because the fault it's trying to detect is the waveforms it's capturing is generated by the fault, not by a machine behind the fault spinning up to produce fault current. So statistical analysis, new chemistries, new power system protection. Seems like there's a lot of opportunity for young people, older people like me to learn new things and apply those to the power system of the future.
You are right. I think this is a very exciting times, because power systems are evolving in such a way that are making us push the envelope in terms of developing technology. And the time domain solutions we have developed are a very good example. New problems, new solutions. And now, fortunately, we have the technology in place to create the solutions for these new problems.
Yeah, and part of our training, I think, is to inspire engineers to come up with even newer solutions to address all these technical problems. I like the way you say these are exciting times, and I can look at it as being two different types of excitement. Exciting in that we came up with a new way to protect, monitor, control power systems, or exciting in that the lights are all out and what are we going to do now, right? And I hope it's the former, not the latter, in our pursuit of controlling electric power systems. My last question for you is, are there things we can do better as an industry when it comes to supporting or providing educational opportunities for students of all ages, including myself being the old guy that I am now?
Well, I would say the industry should, number one, continue expanding training options. I don't see that going down. I see that going up, especially as they relate to new technologies, what we have been discussing here. Another one is to continue increasing online and self-paced course offerings. One more is to invest in equipment donation to universities to enhance their laboratories. I think that the university labs are already good, but if they have the real technology, which is deployed in power systems, and they can play with that technology when they are still in school, that will complete their formation. This will also help professors to get more acquainted with that technology. I think we should, as an industry, continue providing financial support to low-income students. We cannot have the luxury of losing smart students because they cannot pay for the university studies. I think this is something the industry as a whole needs to do, and I know that SEL have been doing that. And I think that we should also increase the training offerings for free. So we need to have a mix of courses for a fee and courses for free in such a way that we help, especially this new generation of students, to continue learning the technology or to get the knowledge they need to have about this rapidly changing technology.
Well, Hector, thanks very much for the conversation. I really appreciate it. My takeaway from this is really just formalizing some thoughts I've had in the past too, is education is so fundamental for everything we do, certainly here at SEL, but for our entire industry, right? And having a well-educated workforce is what's going to take us into the future to having that safe, reliable, and economical power that we all so desperately want and need. Hector, thank you for your time. I appreciate the conversation.
My pleasure. Thank you.
Thank you for stopping by Schweitzer Drive. Join us again as we learn about, explore, and celebrate electric power. For more information about the show, please visit selinc.com/Schweitzer Drive.